Good afternoon, everybody. Hi, my name is Jon Banafato. I work at a mortgage brokerage in New York City called Morty, and I'm also an organizer for a little conference called PyOhio that happens in New York City the first weekend in October. So I hope to see everybody there. Today, I want to talk about passwords. So there's not a lot of prerequisite knowledge needed for this talk, but I want to make sure before we start that everybody knows one thing. Passwords suck. I hope we can all agree on that. Passwords suck for a lot of reasons, but before I get into what those reasons are, I'm going to talk about how they came to be. So when our main concern was a person guessing our password, we came up with a bunch of rules to prevent that from happening. Right? So we spent years and years coming up with these complex password schemes and tricks to prevent other people from guessing our passwords. Then we ended up with this set of rules that makes remembering our own passwords really difficult and allows computers to crack them in no time at all. So I'm sure everybody's seen password rules like this. So we have length requirements with some added bonuses from badly behaving systems, like shorter passwords will be silently padded and longer passwords will be silently truncated. We also get character restrictions. So we'll need one of each of an uppercase character, a lowercase character, a number, and a special character. And good luck guessing what I mean by special character, because my system sure won't tell you. And all of our passwords are going to expire, because we want to keep you on your toes. So by the time you remember your password, it's time to change it again. So if we follow all these rules, we get a very secure password that neither computers nor people can guess, right? This is solid. I got some characters in there, some uppercase, a number or two. So we can use that everywhere and just call it a day. Everything will be fine. Until this happens. So this is the website Have I Been Pwned? And everyone in this room has been involved in at least one data breach. As of earlier this week, the publicly available password lists from this website have 517 million hashes in them. So these are 500 million passwords out there in the wild from one collection from one of the good guys. So how do we traditionally handle this? A common solution to this is a password manager. So we tell people use 1Password or use KeePass or LastPass or any of the other ones that are available. This is a really good stepping stone within our current systems, but they certainly don't go far enough. In particular, they don't protect users from things like those password leaks or from phishing. So I have several hundred passwords stored in my password manager. I'm sure I'm not the only one in the room in that situation. And ultimately, in recommending this solution, we're admitting that there's a problem here, but we're essentially settling on the solution of the users should find a better way to keep track of lots of passwords. That's never really enough, so when passwords aren't enough, we turn to two-factor authentication. Today, we recommend 2FA for sensitive accounts like your bank or your email, your GitHub account, that kind of thing. And most often, what we mean when we make these recommendations is something like a Google Authenticator app on your phone. This is a good answer to the problem of a password leaking. So when someone gets access to your password, but not your 2FA tokens, they can't get into your account, but it doesn't protect against phishing. So it makes it somewhat harder in that a phishing attempt needs to be real time, but a phishing website can steal a TOTP code just like it can a password. And this also continues to push the burden onto the users. We have to make sure we tell them, keep your phone on you so you're not locked out of your account, or keep all of your backup codes in a safe place so you're not locked out of your account permanently. So at best, this is an incremental improvement. So here's what we should do instead. Where possible, let's just get rid of passwords. No passwords means no password vulnerabilities, and we can stop blaming our users for poor password hygiene. Well, we've tried this before. I'm not going to go into too much detail in these attempts, but here are a couple of great ideas that never really took off. So we have this concept of SSL client certificates that you can use in your web browser, and they're a definite improvement from a security standpoint over a password, but they're somewhat of a usability nightmare. Anyone who's ever managed these knows that keeping track of them and especially renewing them can be a huge headache. So because of this, client certs aren't really widely used, and they tend to be restricted to technical users. And then Mozilla Persona was a really interesting single sign-on platform developed by Mozilla that had some great approaches to privacy, but unfortunately shut down in 2016 due to lack of adoption. A community project called Portier continues Persona's efforts, so maybe there's still some hope there. But for now, let's talk about some things that we can actually practically implement today. So these approaches are going to work for almost any website, and they're going to be a better user experience for your users and give you less code to maintain. The first option I'm going to mention is single sign-on. This is already widely used. There are a bunch of different options here, like OpenID, SAML, LDAP. Generally, the idea, though, is to delegate authentication to another service and just stop thinking about it. If this is an option for you, it's a good one. But it can be tricky to get right on the implementer side. So when you're putting your full trust in a third party, make sure you use a security-capable provider like a Google, and also make sure you're using libraries like Django All-Auth or Python Social Auth or something else that does all of the heavy lifting for you. You don't want to be implementing this fairly boring code yourself. This is well documented elsewhere, so let's move on from this. Email-based authentication is an approach that's slowly gaining popularity. Notably, it's used by Slack and Medium today. So if you've never seen it before, this is a Slack magic link sign-in email. So Slack will email me a link in that button, and that includes an authentication token. So I follow that link, and I never have to think about my password. So why does this work? And specifically, why can you trust it? So if your application supports email-based password reset functionality, you effectively already have this feature. Right? It just requires some extra steps from your users. What I mean by that is a user who can reset their password via email can already use that as their only form of authentication on your website. So obviously, this requires that your users have email addresses associated with their accounts, and it puts all password security onus onto your email providers, which isn't necessarily a bad thing. They're already an attack vector through these reset functions, and they're probably more equipped to deal with passwords than your average web application. So let's take a quick look at how we might implement this. So the logic here is so similar to a password reset function that we can basically just reuse an existing implementation of it. So this implementation is taken almost verbatim from Django's documentation on password resets. And in this function, we're going to generate a link with a user ID and a login token. The token is generated by Django's included password reset token generator, so there's no extra code to write there. And we'll take a look at what happens under the hood there. There are a handful of functions called by make token, but this is the one we really care about, this make hash value. We're going to generate a value that is going to be passed to an HMAC function. The result is going to serve as our login token. So everything we're including in this string is significant. The user's ID is unique here. so it ensures that no two users can have the same login token. The password is a source of some random data. Right? In a normal application, this is included to ensure that if a user changes their password, the existing tokens will be invalidated. Because we don't care about passwords, this can really just be a field full of random data and named something else entirely. And if we ever want to invalidate a login token for a given user, we can change what's in the field. The login timestamp is, as its name suggests, the time of the user's last login. Including this ensures that every password or every login token is good for only one use. And the final timestamp just gives us a way to expire a token, for example, after 24 hours. So how do we use this? This Django view is going to load our user and verify the login token, logging the user in if successful. So the important bit here is to call check token. Under the hood, the token generator creates a new hash and securely compares it to the token included in the request. So all of that information we included in the previous slide is now relevant. If any of it changes, for example, the last login time, or if the token has expired, the check token call will return false. The user won't be logged in. But what if we can't use email, or if we don't want to rely on a mail provider for all of our authentication needs? Let's talk about web authentication, or WebAuthn. This is hopefully the future of authentication for websites. This is a challenge response protocol using authenticator devices. So this can include things like your phone coupled with its fingerprint reader, or a USB token like this one. I'm not sure how many people can see it. It's quite small. But this is a YubiKey. It does several things. But one of my main uses for it is as a U2F, or Universal Second Factor Authenticator. So on sites that support it, like Google and GitHub and Dropbox and a growing list, U2F lets me verify my logins by plugging this into a USB port and just tapping the side of it. So not only is this easier than taking out my phone and looking up a code in my authenticator app, it's a lot more secure as well. Notably, it's invulnerable to phishing. So WebAuthn is the natural next step for U2F tech. U2F compatible keys are mostly compatible with WebAuthn as well, so we can start using it right away. How does this work? How are we going to implement this on our backends? Luckily, the PyWebAuthn library provides all the plumbing we need to handle the server side of things. So to build out our backend, we're going to import 5 classes. 2 for generating and verifying registration challenges, 2 for generating and verifying login challenges, and 1 that represents a user. So let's start with the database and build up from there. In addition to the normal fields provided to us by Django's user model, we need to store a few things. The first here, the credential ID, is a unique ID for an authenticator. So this YubiKey has an ID that no other one does. The next field, the public key, is an actual public key that the WebAuthn library can use to verify challenge responses, and we'll see a bit more about that in a few minutes. And the sign count is an integer that we can use to verify that the key isn't malfunctioning and hasn't been cloned. So we'll store all of this alongside the user when registering and logging them in. I'm not going to go through all of the registration and login code line by line. Most of it's boilerplate and handled by the underlying library. But on the Django side of things, we need to implement 4 views. And these correspond directly to the registration and login classes we imported in the last slide. So let's look briefly at some of the more important bits of this. First, we're going to get the user's username and display name from the post body. And then we'll check to see that the username isn't already taken, throw an error if it is. Next, we'll generate a user ID and a challenge and store all 3 of these things, the username, the challenge, the user ID, in the session object. Our user key is just some unique key used to identify the user. It doesn't really matter what's in there. The challenge is the really important bit here. This is random data that is going to be used by the YubiKey to generate a signature. And we'll use all of this later to verify the client and complete the registration. And then finally, we bundle all this back up along with some identifying information about our website, notably localhost here being my domain name, but this would be example.com, et cetera. And we'll pass this back to the client. From there, the client can use the browser APIs to sign the challenge and return it to the server. Once we get the response back from the client, we need to verify it. So we're going to initialize a WebAuthn registration response using our site information, the full response from the client, so this is request.post, and the original challenge, plus a few other details that aren't very important right now, and attempt to verify it. So this will return an error if anything went wrong during the process, such as an invalid or incorrect signature. And finally, once we know that everything is valid, we can register the user and their credential. Subsequent logins look really, really similar, with the small but important change of loading the user's public key from our database to verify the response. So we'll skip the code for the login side of that today, but I'll post all of my code online. And WebAuthn has a functional Flask example in its GitHub repo. One note about the code in my slides, in true conference talk fashion, it has little to no error handling. It leaves out some really important but boring bits, so definitely don't use this directly. Take inspiration from the Flask example in the WebAuthn library if you're going to use this as a reference for any actual development. And now for the part that's sure to break. I have a little demo running on my machine, so I'm going to plug my YubiKey back into my computer. And let's try and register and log in a new user. So I have this wonderfully designed registration form. I'm going to call myself Jon Ohio, because that rolls off the tongue quite nicely. I'm going to click register with WebAuthn, and my browser is prompting me to accept that the website's asking for information about my YubiKey. So I'll proceed. It's looking for me to actually tap the side of that. And that part about being sure to break happens to be true. There we go. I did register, but I haven't logged in yet. So it still tells me, hello, anonymous user. But if I go back to my WebAuthn page and I type Jon Ohio again, I can try and log in. Again, it wants me to authenticate with my YubiKey. I touch the side, and here we are. So no passwords, no phone apps, no email confirmations, just touch the side of this key, and we're in. So the main advantages of WebAuthn here are its ease of use, like we just saw, and its strength against phishing. Google recently released a report about their use of U2F keys just earlier this week, and how they've prevented phishing for all of their 85,000 plus employees for an entire year. They've also recently partnered with a hardware vendor to create their own hardware tokens like this. So it's only natural to extend that U2F logic to our full authentication process. There's a lot of momentum behind this change, and it's coming pretty quickly. The downsides are currently lack of broad support, but it's gaining adoption. When I started working on this talk, it was only supported by recent versions of Chrome Canary and Firefox Nightly, but now it's supported in stable browsers, and Microsoft Edge recently announced support for it as well. So with most of the major browser vendors on board, I think we have a good chance of gaining wide adoption for it. So there's no single authentication solution that's going to fit everybody's needs. In order to choose the right ones, you need to evaluate what's best for your users. For most web developers, though, passwords are going to be a liability. By using a passwordless authentication mechanism, you can avoid the hassle that comes with storing passwords correctly and protect your users in case of an inevitable breach of your infrastructure. So if you take anything away from this talk, let it be this. As programmers, we've mostly failed our users when it comes to authentication. So I'd like to close with a quote from an excellent film. 23 years ago, the plague chastised his coworkers and blamed them for their poor password hygiene. And we're still largely doing this same thing today. So let's fix that together. Thank you.